Hello, Keith Rucker here at VintageMachinery.org. Exciting day for me today because we are back to working on our metal planer, and we are finally to the point where we're starting to put this thing really back together, getting the uprights. That's my goal today. I have the two uprights, one on either side. This is what the crosshead rides up and down on and slides back and forth on. And I want to get these mounted, get them leveled up, make sure they're running square to the table, and hopefully everything is going to be straightforward in this operation. So a little bit of backstory on what we've already done, and I actually did this work quite some time ago. Man, it was back last summer, 6-9 months ago. We started scraping on these uprights. Did that long before I even sent the table off to have it reground, because this was something I could work on at that particular time. And we worked on getting the fronts of these flat and square using a straight edge. Several different areas onto these got scraped, and I'm hoping that they're in good shape. The biggest thing I've got to worry about, I know that everything is good on that face that goes up and that the crosshead goes up and down on. What I have to worry about is getting that square, and that's going to maybe require a little bit of scraping on the bottom of these uprights if it's necessary, and we will see that here in just a little bit. So without further ado, we're going to go ahead and pick up the first one of these uprights. Got my gantry crane set up here, and we're ready to take it on up. All right, going up. Oh, that's as high as it goes. Let's see if that'll clear. I think it will. All right, I want to get a rag and take a little bit of time and clean this stuff up. I've also got some paint that's dribbled down through these holes that I need to get cleaned up. So let me get this ready to go back together. I'm working on getting these uprights ready to bolt back on, and just so you can see how it is, there's 3 shoulder bolts that come through the back side of this, and through this hole, this hole, and this hole. This is a rod that passes through. But these shoulder bolts are very closely fit. They're very precision. And right now, the bolts won't go in because there's trash in there. So what I've done is I've taken an adjustable reamer here, and I've got it set to where it's just barely a little bit smaller than the hole. I'm not trying to enlarge the hole, but I am trying to clean the hole by running this reamer through here. And notice I'm not even putting a tap wrench on this. I'm just turning this by hand. We're just cleaning that out. I'm not trying to remove any metal at all. And now that fits perfectly. So I got one more here to do. This one down here. All right, I think that's got it. And a little bit tight still. Let me see if I can clean a little bit more out in there. Felt a little rough spot in it. Much better. All right, I'm gonna get some Scotch-Brite, I think, and just had a little bit of paint on here I scraped off. I wanna make sure that that's all nice and flat, and we'll be ready to put these back together. I took a minute or two off camera there just to make sure everything was cleaned up. Last thing I wanna do is take my precision ground flat stones, and I wanna stone these sides. This will just knock off any burrs or dings or whatever that's there. It doesn't give me a good fit. I'll do the side and the bottom, and then I'm going to also do down here where it mates onto. All right, I think we're getting ready to lower this in place. Let's see here. All right, that's kind of just sitting on that ledge. These surfaces were all planed originally at the factory, and to have everything square. And my hope is that when I get through here, everything is still square. All right, we're ready to put our bolts in. Let me get some anti-seize to put on these. Got my anti-seize. This will just make this thing easier to come apart if anybody ever works on it again. I know when I took these apart, these things were really stuck in place. It took me a while to break these loose. So, put the first bolt in down here. To get these lined up just right. All right, that's starting in. 1.5 inch bolts here. 1.5 inch heads on them. All right, I'm going to take them where they're just not quite snug yet. Do our next one here. It's going in a little bit easier. All right. All right, I think I'm going to go ahead and tighten all these up now. Okay. And I think we got our upright installed. So this is the instrument we're going to be using to check the columns for squareness. And this is a box square, or some people call it a column square. Basically, it's obviously a square you can measure parallelism. In this, you can measure squareness on either side based on the bottom. Now, this is a Japanese-made level. It was a gift to me from one of my viewers, a good friend of mine, Joel Havens, gave this to me. And this is a crazy, crazy accurate level. It's by far the most accurate level that I have in the shop, which is good and bad. It's good because you can make very precise measurements with it. It's bad because when you get down to the level this one's at, it will drive you batty trying to make a measurement with it. So I don't know if you can see the actual bubble in there, but each line, each division on that bubble says one division equals 0.02 millimeters per meter. This one is calibrated in metric units. Me being an inch guy, I needed to know what that was, and I did the math. It comes out to 0.00024 inches per foot. So basically a 1/4 thousandth inch per foot. And to give you comparison, my Starrett Master Precision level that I have always considered to be an extremely accurate level is a 1/2 thousandth per foot. So this one is roughly, each line on this is roughly 2 lines on my Starrett Master Precision level. So I've gotten this recently. This is actually the first time I've used it. And before I trust it, I wanted to check it for squareness. I believe the bubble's level. I'm not worried about that. Actually, it's adjustable. You can adjust the bubble, and we'll show you that. When we get to the machine, we'll adjust that, make it level on the machine, and then we don't have to worry about if the machine is just perfectly level. It's pretty darn close, but I'm probably going to have to make an adjustment. Let me clean that up, and I'm going to check it with my squareness comparator to see how square this is. So the way we're going to check this for squareness is I have a squareness comparator here. It's basically just a little indicator stand. There's a little beveled nose down here on the bottom. I have an indicator. This is a 50 millionths indicator, so an extremely accurate indicator. And I'm using a Starrett angle block here. This is a piece of granite that's been calibrated. This is calibrated AA. It's about as good of a squareness, something that I can check for trueness is I'm going to have in my shop, and it's going to be really, really accurate. So I'm going to bring in my squareness comparator until that nose touches on the bottom. I'm going to rotate it around, and as that indicator comes in contact with the square, it's going to start rising until you get to right there at the top, and then it's going to start dropping off. So you can kind of look right there. That is perfectly square, or at least as square as whatever this straight edge is calibrated. So, and I'm going to trust it as being square. So I'm going to move the straight edge out of the way. I'm going to bring in my square that we're going to be testing here, and we'll do the same thing. I'm just going to roll this thing around, and it should be 0 if it's square. And we are about 4/10, 4.5 tenths. That's about 3.5 tenths. I don't want to hit it right there because I don't know that I got a good, well, we'll try it. No, that's not. There's a little indentation in there. So, all right, so this instrument, according to this measurement, is off a little bit, at least on that side. That's roughly 6 inches, so let's just say 4 thousandths per 6 inches is 8 thousandths per foot. That's getting close to the resolution of the bubble on there. So, but we got another side. I'm going to flip it around, and let's measure on this side. This side is where you can put it on a bar, but you do still have flats on either side. Let's see what this side looks like. That is just shy of a 10,000th of an inch. About the same on that one. So so that's 2 10,000ths per foot, which is, again, actually, it's a lot better. It's still about a bubble off, according to the level there. Looks like I may need to send out and have this reground to get it trued back up, because it is not perfect, but I think it's going to be fine for what we're doing. I just need to know, I need to figure out which direction it's off, so that it's basically the equivalent of a line off. So when I go up here and I move one line, I'm still going to be square. I think I can work with it. I need to just work off of this side here. All right, guys, I did some a little bit closer inspection on this without the camera in my way, where I could really get in there and look at it and really get futzy with it. And what I've determined is that it is basically off by one line, one division, and it's basically what I need to do is, when I'm reading the bubble, obviously it's not level right now, but I need to, in my mind, move the bubble mark in this direction. I put a little arrow mark up there, one line, and it's going to be pretty close. It's probably not exactly one line, but you know, we're measuring tiny amounts here, so that's going to get me close. And I need to measure off of this side over here. I'm going to put a star right there, and that way I'll know that I need to use this side to measure with. I'm over on the planer now. I've put my fail level up here. This level is an all-way level. It tells you the levelness in all directions. There's lines in here. There's a bubble in the middle, so it's kind of like a bubble level. And each line on this one is a 1/2 thou per foot. And it is within, it's not exactly perfectly level, but it's within a 1/2 thou per foot in all directions. So I'm not going to try to level the table up anymore, at least not now. I may try to fool with it later on. But I've also set this level up. And if you remember, I told you got this set screw here. I can adjust my bubble to make it level. So I'm going to say, okay, the table's level. So we've got I have set here, it took me about 20 minutes. This thing is so ticky, it's so fine. Just a tiny movement on this will move it a line or two. But I finally got it where it's basically the bubble is reading right on the forward line up here in the middle. And I can work off of that. So I'm going to be looking at this, and we can go from there and calculate how square we are. So let's do it. Let's go over here to the column now and see how square it is. Pick this up. We've got a little thermal protection here. I'm going to use a rag just so the heat of my body doesn't change this. We'll come over here to the column and put it up on here, and let me read my bubble. It's slowly moving back in this direction. Okay, so we're about, okay, it's still moving. We're about 2 lines off from where we started from. I need to adjust that one, so about 1 line off of square. I'm going to check it in a couple of places. I suspect it's going to read a little bit different. Let it go back to 0. And that one's about 2 lines. All right, so after a lot of measuring and double checking and going back and forth between this level and the table, and I'm still, I mean, depending on where I put this level down on the table, I'm getting about 2 bubbles variation. I mean, it's such an accurate level, it will drive you batty. But according to my calculations, this arm is leaning backwards by about, it's roughly a 1,000th per foot, or roughly 1 millimeter per meter. I don't have a really precise number because my numbers are bouncing around a little bit. Here's my game plan. I need to tilt it forward just a touch. Again, 1,000th per foot, not very much at all. The base down here is 2 feet long. I'm going to take a piece of 2/1000 shim stock, put underneath this back edge. I'm going to kind of take this thing loose. We'll put the shim stock in there, put it back on, tighten it back up, and see if that doesn't move it forward. Hopefully I got enough play in these bolts that it will allow me to get everything to line back up, and we'll check it again. So let me do that, and let me go off camera, get that shim put in, and we'll check it again. I think that did the trick. So I just went and got a piece of 2,000 shim stock, like we said. I unbolted the 2 back bolts. I loosened the front bolt. I came in here with the gantry and just kind of picked the back up a little bit, slid this piece of 2,000 shim stock, that's the other half of it right there, up underneath there, pushed it back down, put my bolts in. Fortunately, my bolts still aligned up just fine. I didn't have any alignment issues there. I was worried that they were so tight that by raising it up, I might have gotten them out of line, but they were fine, snugged them back up. Came in here with my column level, and we're within, after making our little adjustment, within a 1/2 line of being on. And so that's, I'm gonna say it's within 1 millimeter per meter. And I went also, and I've looked in my reference book that I've got. This is called Testing Machine Tools by Georg Schlesinger. And unfortunately, this book is out of print, but there is a copy of it you can download off the internet. I have found a copy. And I looked up in here for planers, what is the permissible error for squareness on these columns. And it says that it is, as long as you're within, I think this is German, what it was originally written in. So all the measurements are in metric. It's 0.03 millimeters per meter. I'm down to about 0.01 millimeters per meter. So let's see, he's got a conversion chart in here. 0.03 millimeters per meter is about 3.5 tenths of a thousandth per foot. We're down to 1, which is about 1.2 tenths per foot is where we're at on this, and that is well within spec. We're leaving it alone, and we're going to put the other column on. Same process. I'm probably going to do that one off camera. We'll bring you back once we get them both in here. All right, the second upright is on, and it went a lot easier than the first one. I basically knew what I was doing. So when I checked it for squareness with the square, it was leaning back about 2 millimeters per meter, which is within spec. That's about, what is that, about 1/4 of a 10,000th per foot. I got a 2-foot area down here, so the smallest shim stock I have is a 1,000th piece of shim stock. And basically, if I'd done that, it would have made it going 2 millimeters per meter forward. So I decided we're just going to leave well enough alone. That is within spec. Again, 3 millimeters per meter. Anything underneath that is in spec. It's within 1 millimeter per meter of the other side, which I'm tickled with. I think we're golden and did not have to make any adjustments to it at all. So there you go. We have our uprights installed. One thing that was interesting was I had my level all zeroed out over here. I came in here, I put this upright on here, bolted it down, went over there and looked at my level. Just the weight from this extra upright on here actually moved this about 3 lines or about 2 lines on the bubble. So again, extremely sensitive instrument there, but I'm confident we got these within spec, and we are moving forward on this rebuild. Next, I got some things I got to make, machine, remake or whatever. There's some threaded rods that go in here that raise and lower the cross piece that goes across here. And we've got some work we got to do on that. So that'll probably be the next thing on this before I can really start putting any other pieces on. But we're definitely moving in the right direction. So guys, that's going to be a wrap on this episode. As always, thanks for watching. Appreciate everybody out there following along with this series. Been getting a lot of comments, a lot of people, a lot of emails, a lot of people just contacted me, telling me how much they're enjoying this series. So I really appreciate that. Appreciate the feedback. And with that, guys, as always, if you haven't already, please subscribe to the channel. Comments are appreciated, as are those thumbs up. And guys, we'll catch you on the next video. Thanks for watching.